All right, we're on kind of the top, just below the top part of page 2 where it says changing a percentage increase or decrease to a growth or decay factor. It says to find the growth or decay factor from a percentage increase or decrease. You're going to change, first thing you're going to do is change a percent to a decimal. For an increase, you're going to add the decimal to 1. For a decrease, you're going to subtract the decimal from 1. 1 as a decimal would be 100%, right? So if you subtract something from that, you're going to have less than 100%. You're going to have a number between 0 and 1. You're going to end up with a decay, right? If you have a growth factor, you add 1 so that your number is greater than 1, so you're showing growth. Okay? And we'll just get to that. It says in 1989, the population of someplace, Colorado, was about 529,000. The population growth rate has been about 2.3% per year. At this rate, estimate blah, 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 blah. So, well, let's talk about what these first things are. What was my initial value? Well, that would be the A. That would be your 529,000. Does that kind of make sense? Okay, my growth rate was given at 2.3%. One of the things you want to do, the first thing is you want to change your percents into decimals. That just means I'm going to drop my percent, move my decimal 2 places, I end up with 0.023. So far, so good?
Yeah.
Now, this is a growing, correct? So to find my growth rate, I'm going to add 1 to this number, 1 plus 0.023 to get 1.023.
That's it?
So far.
Okay.
We are going to use this information, and this information in this formula.
Okay.
Is that kind of making sense? So A is my initial value, B is my growth rate. X has to deal with whatever my question is here. So let's see. We'll write out what we have. We have Y equals 529,000. That's a comma. It's the biggest comma ever. 1.023 raised to the, well, this is what we have to figure out. It says part A, someplace population in 1998. So I would just
would
take
that be
1990. Is it 98?
Yeah.
Yeah.
Minus.
Does it matter that that's 9 years after?
No, I mean, because if I do 1998 minus 1989, I'm going to get 9.
I didn't see that you're doing minus 1989. Okay.
And then I can just plop this puppy right in to my calculator. So let's plug in 529000, and then put your base in parentheses. And then you're going to use your caret to raise it to whatever power. And in this case, you could actually type in that, or you could just put 9. And you're going to get Y is approximately 649,137, folks. Is that okay? How you doing with that, Katie?
Good.
Yeah? Sweetness. All right, so that's going to be part A. Let's look at part B. It wants to know some places population in 1970. Well, we're going to start the same. We've got Y equals A, B to the X. We know that our initial value was given as 529,000. We know that our growth rate is 1.023.
Well,
and hold on, hang in there.
Okay.
What year did we start?
it started 1989.
1989, well, 1970 minus 1989. So what's that going to give us for an exponent there? Negative what?
$19.
Right? And we can just plug all that in, right? So what's that negative going to do to this, right? It's going to make it as 1 over this. So actually we're going to be able to calculate backwards, which is pretty sweet, I think. I ended up with 343,000. $414. And I just truncated the decimal there because I didn't want halves of people walking around.
Yeah.
Yeah.
That would be pretty.
Yeah, I'm confused because the calculator comes up with like decimal numbers, and how could that be possible for there to be only like a fourth of a person and stuff like that?
Well,
it's-
you're smarter. The calculator's just doing the numbers. You're smarter than that, right?
yeah, the calculator
Well-
doesn't know there can't be half a person.
Right. So typically,
Or a point-
whenever you'd have like 0.5 of a person,
0.24.
you'd go ahead and count another whole person in there.
Okay.
Okay, that's what you do. You usually round up and count them.
Okay.
But it all depends on what you're looking at. So, all right, let's pause that for a second. We're on fire. Okay, we're at the bottom, last example on page 2 of Exponential Functions, page 2 at the bottom. And this is about car depreciation. And it says a car costs $14,590, and it loses 30% of its value each year. Each year it loses 30% of its value. Find the value of the car in 5 years. Okay, so we're talking about a loss of value here. Would you agree?
Mm-hmm.
Which is what? A growth or a decay?
Decay.
A decay, which tells you that your base here is going to be between 0 and 1. So far, so good?
Mm-hmm.
When you're finding your decay, first thing, let's look at our rate here. Our rate of decay is 30%. We're going to change that into a decimal, which would be 0.3. In order to find our rate of decay, we're going to do 1 minus 0.3, and that's going to give us 0.7.
Mm-hmm.
Are you okay with how we found B?
Yes.
Sweet. Now, can you tell me what my initial value is?
14,590.
That is correct. They gave it to us. It says a car costs this. That's your initial value. Let's go ahead and plug in what we know. We know Y equals 14,590. We know that my base is 0.7. What we need to know is what we're going to plug in for X. What would that be?
5.
It would be 5. Let's just talk about that for a second. If I were to put 0 here,
Yeah.
right? If I put 0 here, that would make this 0.7 to the 0, which would be 1.
Yeah.
Which means at times 0, which is when I bought the car, it would have cost me that much.
Yeah.
Do you see what I'm saying?
Yeah.
So if I put 1, I would be finding out, ooh, how much this is decreasing.
In 1 year.
Do you see what I'm saying? Okay, so far so good. So when we do this and we plug this into our calculator, we're going to get 14,590. 0.7 in parentheses using my caret, raise it to the 5th. I got, find the value of the car. Woo! It is just amazingly worth $2,452.14.
Mm-hmm.
I'd buy that car.
14 cents. I'd like
If
that
it's
car.
only 5 years old and
That's pretty
costs
sweet.
that much.
That's a pretty sweet deal for a 5-year-old car.
Oh yeah.
But you're thinking 14,000 when you bought it.
Unless it has no engine.
It wasn't a big car when you bought it. 'Cause,
Yeah.
you know, Honda Civics are 22, 23 now. It's insanity. You can get the Chevy Aveo or the what's the little bitty Kia? What's the little bitty Kia? It's a little bitty thing.
Don't know.
That'll be in that price range. Okay.